Hello and welcome to my presentation about the demo exploration and analysis of temporal property graphs. So my name is Christopher Rost. I'm a PhD student of the University of Leipzig. And because we just have a 10-minute slot, we will directly start with the presentation and the demonstration. So just to introduce, our demonstration is not just working on the property graph model, but on the temporal property graph model. It is mainly an extension of the property graph model with two big extensions. So we have logical graphs and graph collections in addition, but these are not focus of the demonstration today. And we have a bitemporal modeling. So this is important. That means all vertices, edges, and also logical graphs in our case have two time intervals assigned. So the first one is the valid time interval. That means, okay, when this vertex or edge is valid in the real world, so when that happens in the real world. And the transaction time interval represents the time when this information was inserted in our graph or was deleted there. Okay, for more information, visit our paper or our previous publications. And our demonstration is about the temporal graph explorer. So you will see here the architecture. So in the middle, we have the Hadoop system, a distributed data flow system developed at the University of Leipzig. You have the graph model inside and a meaningful API at the top. And at the bottom of Hadoop, or Hadoop is based on Apache Flink for distributed execution. And on the left side, we have a visual demonstration I will show you today. And we have also a programmatic demonstration you can view in our demo paper. Okay, so to start, I will switch to the temporal graph explorer. So this is it, it's a web application. And you will see here at the top, we selected three different operators for this demonstration. So a snapshot operator, difference operator, and a temporal grouping operator. Okay, so let's start with the snapshot operator. Snapshot operator extracts a point in time or time interval from a given graph history. You can select a predicate type here and one or two timestamps depending on the predicate and the time dimension that should be considered. Okay, for our example graph, I selected transaction time and as of predicate and a timestamp here, December 2020. When I execute that, the graph is our result. So we have here several persons with some properties. We have interactions between them. We have a forum here and some text. And the interesting part is here that we see, for example, Bob has gender male and lives in city Leipzig. So now when we change our timestamp here from the SF predicate to 2021 in January, executing it, then we see that Bob not longer lives in Leipzig, but in Berlin. And you will also see that from this transaction time information here, that this vertex is transaction from timestamp is in January 2021. That means he changed his location. And to see the difference between these two snapshots, we provided the difference operator. So the difference operator compares two snapshots in time and shows the difference between these two snapshots. So we select again our example graph, the transaction time domain, and as of predicate for 2020 in December, and a second snapshot, also an as of predicate 2021 January. Okay, we now want to compare these two states of our graph. And what we can see here is that we have two Bob vertices and its edges. We see here Bob living in Leipzig until January 2021, and from January 2021, Bob lives in Berlin. Yeah, so this is colorized to see the difference, and all gray vertices and edges means that nothing happened to these vertices and edges between these two timestamps, so they are included in both snapshots. Okay, so these are a snapshot and our difference operator. Now we will come to the last one, the grouping operator, and we have 5 minutes left. So The grouping operator summarizes the graph, or summarizes a huge graph by several key functions. So key functions mean like the grouping keys, so on which characteristics the vertices and edges should be grouped together. And each vertex and edge group can then be, or some aggregation functions can be applied to these vertex or edge groups, and an aggregate value can be calculated. So again, we decide to take our example graph, so we can click show the whole graph to see again this complete graph, and then apply this default grouping configuration. So group vertices by their label, group edges by their label, and aggregate by counting them. And we see here, okay, we have 3 types of vertices and several types of edges, and in the brackets behind we see the count property, and also as a separate property assigned to these vertices and edges. Okay, so let's now choose another bit more complex data set. So from the linked benchmark council, the social network, when we say show the whole graph, we will see a big amount of vertices and edges. So here, okay, and we again group them by these default grouping configuration. So we see the schema of this graph in a few seconds. Okay, so we see, okay, we have persons, posts, text, and so on, and several types of edges here. And now we can define some filters, because we are just interested in forums, in person, and universities. So we can apply that and see, okay, we filtered these groups. And now we can see, for example, we didn't know for this group forum, okay, when these forums were created. So we add another grouping key function. We say, okay, we want to know the vertex timestamp for forum, for the valid time domain, the from timestamp, and the year when this forum was created. Execute it again, and we see this forum group splits in 2 groups. So 95 forum vertices were created in 2010, and 5 were created in 2011. Okay, so you see, as grouping key function, you can also apply some grouping keys that depends on the time. So now let's select a bit our city bike dataset. So the city bike dataset represents city bike stations in New York City as vertices, and bike rentals as trips between them as relationships. Okay, so again, show the summary graph of that example graph. So we have 3 stations and more than 1,700 trips. Now we add another key function, for example, property, a vertex property on longitude, and vertex property on the latitude. Execute it again. And if we have a latitude and longitude information on our vertices, then automatically a map view will be created, and the points are set on that map. So we see here we have our 3 stations and the relationships between that stations. So this is just an introduction to these map view. And now we can now say, okay, we will group them on the name of that station and add some other aggregate functions. For example, we want to know the minimum duration, the maximum duration, and the average duration of our bike rentals between these stations. And the granularity are minutes, for example. Okay, here, executed. So we are running out of time. And we see now, okay, each edge has 3 additional properties assigned. So the minimum duration in minutes, so your 1 minute, average duration 27 minutes, and maximum duration 580 minutes. Okay, and now I think you got a feeling what the Temporal Graph Explorer is. We have a lot of more functionalities, and I hope I will see you at this 1-hour demonstration. And I would say thank you for listening, and stay healthy, and thanks for your attention. Thank you.